started on some exponents and some square roots. And we'll get as far as we can over the next hour. And we'll call it a day. Try to zoom in hopefully without getting the yellow screen. All right. This lesson introduces you to exponents and square roots. Yes, sir.
What about makeup?
Yeah, see Mr. Lee, I was looking for you. He'll help you with anything you need there. Anybody else need any time to do some makeup work? Now is proper time. All right, so let's talk about exponents and square roots. Even though exponents and square roots are not normally used every day, they do provide a convenient way to express numbers. Now this is different when the exponents are still the same when we talk about 4 times 10 to the second power, but now we're going to talk about numbers other than 10 to a particular power. So you see here we have an exponent of 3 squared, or 3 to the second power, and we have the square root with the radical symbol and the 9, and we'll talk about each of those here in a moment. Exponents are widely used in finding the area of squares and circles. When we talk about an area of a square, all we got to do is talk about like if a house is 20 foot square, that'd be 20 times 20, or the square of 20. And for a circle, it's pi r squared is the formula for the radius of a circle. I keep forgetting I can touch the screen, except in this case. I guess because I have it warm up. There we go. And if you know the area, you can find the side of a square and the radius of a circle by using square roots. We're going to see that. Exponents are a way that we use to express very large. We've already talked about positive exponents and negative exponents being able to represent powers of 10. So 10 to the 12th is literally 10 times 10 times 10 times 10, 12 times. And that's how we get 10 to the 12th. 10 to the negative 12th is 10 divided by 10 divided by 10 divided by 10, 12 times. And that's how we get 10 to the negative 12th. So let's begin. All right, exponents are used to express repeated products. Before, when we had like 10 to the second power, we were saying 10 times 10, or 10 to the fifth power, 10 times 10 times 10 times 10 times 10. But in this case, we're talking about a number other than 10, and in this case, we're seeing 2 to the third, or 2 cubed is another way that can be expressed. And that gets back just like we did with the powers of 10, 2 times 2 times 2. So what is 2 times 2 times 2? 8. So it's literally 2 times 2 times 2, which gives us a product of 8. So we see the number 2 here is called the base, and the number 3 is called the exponent. So the base number is whatever we're multiplying over and over, and the exponent is the number of times we multiply it. And the exponent is going to be written above and to the right of the base number. So, we want to make sure we don't write it where it's hardly distinguishable, something like that. The 3 is smaller, but 1 it's kind of in the middle and it's not in the upper right, so it's hard to distinguish that number against something like that. So this is your base. And this is your exponent. All right, so which of those is the exponent, the 9 or the 5? 5. And what does that translate to literally? 9 times 9. Exactly. There's our exponent. So apparently this persnickety screen is not liking that. All right, which one is the base? The 2 or the 3? 2. 2 is 2 to the second power, or 2 squared. Either one of those is perfectly acceptable. We typically say for the second power for the exponent of 2, we can say squared. For 3, we can say cubed. After that, it's typically the base to the 4th power, or 5th power, or whatever the case might be. And again, 2 to the 4th. So a base of the number is either represented by A and the exponent is represented by N. And remember, the base and the exponent can be any number, so we can express any number that way. How do you pronounce that right there? Yep, so the base is first, and that would be 4, and then the exponent would be the 5th power, so 4 to the 5th power. Which one of those is 10 to the 6th power? C. Yeah, we have 6 to the 10th power, 10 to the 3rd power, or 10 to the 6th power. Let's go back a slide. What would 6 to the 10th power be? Nope. See, we're confusing our 6 times 10 to the 10th power. We'd have to take the calculator. We'd have to say 6 times 6 times 6, not 10. Wow. Wow. Tell us a Monday all the way around. All the way out times 6, and this will be the number 10. So it would be 6 times 6 is 36, times 6 is 216, times 6 would be whatever, and we would just keep going until we got it. How about 10 to the 3rd? Yep, that would equal 1,000. And how about 10 to the 6th? What would be? So that would literally be 10 times 10, 6 times. And again, in this case, this is either 2 squared or 2 to the 2nd power, which is literally 2 times 2, which equals 4. The exponent indicates the number of times the number is multiplied by itself. Again, we've already talked about that. It gets a little confusing when we start talking about the times 10 to the 6th or versus just 10 to the 6th power or 6 to the 10th power, because our mind wants to revert back to where we were on powers of 10 earlier. But here the exponent is 3, the base is multiplied by itself, so literally 2 to the 3rd or 2 cubed is 2 times 2 times 2. And 3 to the 4th power is 3 times 3 times 3 times 3, so 3 times 3 is 9, times 3 is 27, times 3 again would be 81. So 3 to the 4th literally equals 81. All right, 10 to the 6th, we've already done that, but again, 10 times itself 6 times. I know some of you on that side can't see. I'll try to at least put that way so it's a little more apparent to you. All right, now how about fractions? Here's where we start throwing the curveballs. It works the same way. It just makes for a much wonkier number. 0.5 to the cube or to the 3rd power is quite literally 0.5 times 0.5 times 0.5. It's because it's fractional. It's going to get smaller. So when we break that down, it becomes 0.125. How about 4 to the 3rd? What number does that represent?
64.
4 times 4 is 16, times 4 again would be 64. How about 2 to the 5th? 32. 2, 4, 8, 16, 32. 2 to the 5th. Zero 0.7 cubed, or 0.7 to the 3rd power. I know which one it is. If it's the right answer or not, it could have a wrong answer up there, but whatever 0.49 times 0.7 is. And that's because we know it's gonna get smaller, so it can be in those, 0.7 times 0.7 would be, 0.49, then times 0.7 again, would give us 0.343. All right, so let's talk about a few more facts. We'll talk about power of 1, power of 0, negative bases, negative exponents, we'll get each one of those. Any number to the power of 1 is equal to that number. So what's 1 million to the first power?
1 million.
What is 5 to the first power?
5.
What is 122 to the first power? That's a pattern there. So any number to the first power is that number. So it doesn't matter what the number is. 0.25 to the first power. Y'all are doing so well. Yeah, 0.25. Okay. And a base number with an exponent of 1 just simply means that number. It's not multiplied by itself. It is that number. So if you see something literally to the first power, just remove the number, the exponent, and you've got the answer. Now, any number to the power of 0 is equal to 1. So what is 0.3 to the 0 power?
1.
What is 184 to the 0 power?
1.
1. Always 1. Anything to the 0 power becomes a 1. And note that 0 to the 0 power will break your calculator. It's undefined. So, negative bases. Numbers with negative bases produce a positive number if the exponent is even, and a negative number if the exponent is odd. And the reason for that is, what happens if we multiply a negative number by a negative number?
To be a positive.
You get a positive. But if we multiply a negative number times a positive times a negative, what do we get?
Positive.
A negative times a positive times a negative. You get a negative. So that's why every even power, if it's a negative, is going to be a positive. Every odd power will be a negative, because if it's a negative third, right, to a third power, we would be saying -2. Let's write it. We'd literally be saying, so if we had -2 to the third power, that would be -2 times -2 times -2. Minus times a minus is a positive, times a minus is a negative. If we went one more, an even, it's going to be a positive. If we went one more, it's going to be a negative. I'll put a times there. So just remember, a even number exponent for a negative number is going to be a positive, an odd number is going to be a negative. That will always hold true simply because 2 makes it even, 3 makes it uneven, and every time we go up 1, we're changing that sign each time. And I don't have it next. There we go. All right. So again, this follows those same rules. If we're negative times negative, we get a positive. Negative times negative gives us a positive. Times negative again will result in a negative. Numbers with negative exponents produce the multiplication inverse or reciprocal of the number. So 2 to a -2 becomes 1/2 squared. So what we would do is we have 2 here to the -2, right? We would write the inverse of the base first, which is 1/2, correct? The inverse, because this is literally 2/1. So if we write that inverse, it becomes 1/2. And what happens is this sign, this changes sign. So instead of a -2, we have a +2. So first, invert the base. So 2/1 becomes 1/2. The 2 stays with the 2 here, but it becomes a +2 because it's on the inverse of that. So then we can do the math, and then we end up with either a quarter or we convert it to a decimal fraction, 0.25. So we'll see some others here in a second. Hopefully, if I know nada. Maybe not. What number does 2,556 to the 0 power represent? 1. What if it were to the first power?
Yeah.
Right. Yep, exactly. All right, here's one we can do. What number does -2 to the -3rd represent?
Maybe -1.125.
All right, let's see why. So again, we started out with -2 to the 3rd power. Well, -2, it's -3rd. Thank you. There we go. I can't stand that, I'm a little OCD. -2 to the -3rd. All right, -2 is really what? -2 over what? 1. So if we go ahead and do that and get the reciprocal, we end up with 1/2. Now the 3 stays with the 2, but it's no longer negative, right?
Right.
So that becomes 1/2 times 1/2 times 1/2. So one times 1 times 1 is 1, 2 times 2 times 2 is 8. 1/8 in decimal form, 0.125.
But what will you do with that negative if you?
Ah, I forgot to bring the negative, you're right. This would be a -1/2. Very observant. Fault the teacher there. So let's go back and talk about that. You're absolutely correct. That's why our answer was correct. So we had a -2 to the -3rd, right? Now the 3rd changes signs, but we're still at a -1/2. The reciprocal of -2 over 1 is still -1 over 2. So this literally becomes -1/2 times -1/2 times -1/2, which results in -1/8, which we divide 8 into 1, we'll get -0.125. That's what happened to that negative. The instructor forgot to put it there. Dropping signs, at least on my part, was one of the biggest reasons I failed math tests. As I told somebody before, if I had 50% for every math test I ever failed, I'd have $8.22. I'll let you think about that for a minute. But dropping those signs will bite you, especially if the material's cruel enough to add an answer that works without the sign. In this case, it was. All right, we're gonna practice. Give me just a second, don't yell it out. Give everybody a second to kind of marinate, and then we can all yell it out. 2/3. 8. All right, give everybody a second. 5 to the 3rd, I'll call it out in just a minute. Five to the 3rd power. 125. 5 times 5 is 25. Times 5 again would be 125. Oh, 0.12 to the 1st. Go ahead. 0.12. Everybody at one time. Remember, the first power equals the original number. The 0 power equals what? 1. Fat fingers. 32 to the 1st. 32. 10 to the 0. 1. Any number to the 0 is 1. So if you're, 0 power, you're number 1. What is 321 to the 0 power? 1. 2 to the negative fourth. Give you a minute. Let everybody kind of dwell on that one, then we'll work it. Oh, the free manicures are the one on North Campus. Sorry. So if you don't mind traveling to Thundersville. I was so counting on that letter today. Just gonna have a spot of tea and a manicure. All right, so what do we get? 2 to the negative fourth.
Negative 15.
Hmm?
0.625. 0.0625.
Sounds like we need to talk about that one a minute. All right, so we have 2 to the negative fourth. So we gotta do what to the 2? We gotta reciprocate it, right? 2 is literally 2 over 1, so if we take the reciprocal, that's 1 over 2. And then with, to the negative fourth, this becomes positive when it goes, once we take the reciprocal. So that literally becomes 1/2 times 1/2 times 1/2 times 1/2. 2 times 2 is 4, times 2 is 8, 1/16. And if we want to express it in a decimal form, what would it be?
0.0625.
Yep, 0.0625. So either one of those should work. And it should take the 1/16. Okay, we've already done 3. Well, I need Greg's free to see if he tested out or not. Has he got anything else in his letters or? I measured break. If it's not this, you'll have to type it in for me. It's not that. Oh, but I'll answer it.
Yeah, I remember that.
All right, so let's try this. See if it'll take 1/16, and it would probably take both. It would probably take 0.0625. All right, -3 to the third. Give everybody a second on that one. -3 to the third. So what is -3?
Negative 27.
Is -27 or -27? Because -3 times -3 is what? +9. +9 times -3. -27. Okay. All right, let's give everybody a moment on this one. -3 to the fourth power. -3 to the fourth power. All right, -3 to the fourth.
81.
Yep, -3 times, or -3 times -3 is a +9, times a -3 is a -27, times a -3 becomes a +81. Negative times negative is positive. All right, give everybody a moment on this one. -5 to the negative second power. -5 to the negative second power. right, let's work that one. Let's get an answer first. What is it?
Oh, 125th, yeah.
All right. So first of all, we start out with minus 5 to the minus second power. I'm gonna see if I can do this without blowing it this time. So minus 5, we gotta do what to it? Invert it, but it stays what? So it becomes minus 1/5, right? And this goes with the 5, but what happens to that minus 2? It becomes positive, right? So literally what we're saying is minus 1/5 times minus 1/5 equals what? 1/25? Or we can convert that decimal to what? 0.04, right? So we did the fraction a while ago. Let's make sure we'll take the decimal. Hooray, we did. All right, we've completed the practice. And I hate where that keyboard is. I do that every stinking time. All right, we'll move on to the next lesson. We'll do the summary real quick. And exponents are used to reduce, to express repeated products. So this would be a to the nth power. So n would represent some number. So it would be a times a times a times a, however many that number is. The a is the base and can be any number. The n is the exponent, can also be any number. Numbers with exponents are pronounced, in this case, a to the nth power. The exponent indicates the number of times the base, so it would be a times a times a times a, however many times that n represents. A negative base with an even number exponent results in a positive number. A negative base with an odd number exponent results in a negative. So we see a negative number as our base. We're talking about our base only. Negative 2 with an even is going to give us a negative number. So this time it's a 2. So negative 2 times negative 2 becomes 4. Same negative 2, this time 3 times. Negative 2 times 2 is 4 times negative 2 is 8. Not in? All right, give me just a second. Oh, if you'll log in under U and click on that test and say edit the test options, it'll show you what that password is. And if you can't get it, holler at me. Okay. A negative exponent indicates the multiplication inverse or reciprocal. So first thing we have to do is invert a, which is a over 1, becomes 1 over a. The exponent remains with the a, but it becomes positive rather than negative. A number with a power of 1 equals the base number. A number with a power of 0 equals 1, and 0 to the 0th power, like I said, is undefined. If you put that in your calculator, it will barf all over itself. All right, let's go on. Let's do some square roots. I don't really say square like that. I say square. But a square root is the base of a squared number. So 2 squared equals 4, and the square root of 4 is equal to 2. And we represent the square root symbology by doing the radical sign here. The square root of a number is a number which, when multiplied by itself, gives you the original number. So obviously the square root of 4 is 2, therefore 2 times 2 equals 4. And we talked about the radical sign already. That's that little sort of like a check mark with a horizontal line. An alternate radical sign uses the number 2 to indicate a square root. I had never seen that before, neither. Maybe I hadn't had enough college stuff behind what I'm taking, but I will not have anything on the test that looks like that. Obviously, they're trying to say like a cube root would have a 3 there or whatever. Maybe I've been too long removed from that. All right, 2 squared equals 4. And again, the radical sign represents a number that will multiply by itself and give that product. So what is the square root of 25?
5.
5. We know that. A lot of us have those square root tables memorized. We remember that, you know, it's 9, 16, 25, 36, 49, and so forth. If you're taking Common Core math, I don't know what they're doing now. Probably not even teaching square roots. So we solve that one. In general terms, the square root is where b squared equals a. So we've got a radical, a squared number that we're looking for the square root, and the result is b. Then if we take and square b, we come back to a, which is what is up under the radical sign. That's just a fancy way of saying if a is equal to 81, b is going to be equal to 9. So therefore, 9 squared, b squared equals 81. And you could substitute any numbers there. If this was 125, 25, I'm trying to get a different number. Let's say 49. So this would be 7, and of course 7 squared equals 49. So I was getting confused. So again, it's just trying to say that if we take the square root of the number, which is a, we're going to get b, and if we then in turn square b, we're going to be back to a. That's all that's really expressed, as long as we don't have a 0 for any of those. If we do, it's not gonna work. Fractional exponents can also indicate square roots. 9 to the 1/2 or 0.5 power. And again, I'm not going to be expressing it like that. But anyway, there's that. And as you might have guessed, there are many types of roots other than square roots. There's cube roots, the 4th power, so forth and so on. We'll get into those as we go along. And we're going to talk only about square roots. So if you're worried about cube roots or anything larger than cube roots, you've come to the wrong place. We're going to be talking about square roots and square roots only. What is the number that when multiplied by itself equals the product written under a radical sign? That is a fancy way of saying square root. Which expression, I want to bring it down a little bit. Which expression signifies square roots? Yep, the radical sign. So we're trying to find the square root of a. This is a power of a, and this is real, at least for our intents and purposes. What's the square root of 36? 6. Up to this point, square roots were easily calculated. We're taking numbers that we already know pretty much, but we're going to talk about maybe some that we don't. However, finding the square root of 2835, probably not that easy. And we're going to do a modified division form here. All right, so first, separate the numbers into groups of 2 starting at the decimal point. This is not my favorite way of doing it. We're going to try to get through it. All right. So here are some additional examples. Like we had 7, we would write it as 0.7. We had 127.1, we would add another decimal to get us, or 2 more decimals, and so forth and so on. We're going to take them one by one. But anyway, we're trying to get it where we can group it in groups of 2. And that's by either adding leading zeros or lagging the zeros here. All right, so if we had 4.8, remember we have to work off the decimal point. Which one of those would we use? Yeah, we put a 0 in front of the 4 and a 0 after the 8, and we would break it at the decimal point. And we'd have to make a 2-digit number before the decimal, a 2-digit number after the decimal. All right, so let's do that. 2835, and we've kind of brought it into 2 groups. All right, start with the first group on the left. Find the number that when multiplied by itself will give an answer as close to the first group as possible. So it can't be 4 times 4, because we can still get 5 times 5, which is 25. And if we go 6 times 6, that gives us 36. So we wind up with 5 times 5 is 25. That goes into, subtract it from 28, gives us a 5 up here, brings a 3 down here. So again, it kind of went through every scenario. 4 times 4 didn't work, 6 times 6 didn't work, but 5 times 5 put us as close as we could to the 28 and gave us a remainder of 3. All right, now we're gonna drop down the next group, the 335, and let's see what we do. So, so we're gonna double the quotient. 5 times 2 equals 10, let's see where we're going after that. 10 times 2 equals 20, 10 times 3 equals 30, and 10 times 4 equals 40. So it's not hard to see we're gonna end up with 10 to the 3. So we're gonna put a 3 over here. We're gonna put a 103. Why did they put the 0 there? Because it was 10.
Yes, 5 times.
Right, yeah, 5 times 2 was 10, and then, yeah, 3 times 335. And we're gonna subtract 309, which is 103, and that's gonna leave us 26. And 53 times 53 equals 2809, and we're gonna have a remainder of 26. And we're gonna put 2600, add 2 more zeros, 2 more groupings. And we're gonna do 53 times 2 equals 106. Good Lord, who wrote this? Well, I'm gonna show you the way we're gonna do it in just a moment. We're gonna go to a little whiteboard, and it may even work this. But I'll show you how I do these numbers. And the good thing is you won't have to worry about this, and in fact, we may just skip this entirely. I didn't realize this is not the same one that I use in electronics. I accidentally populated you with the wrong number here, but let me pick a number momentarily. Here we go. Let's see if I can remember my way before I blow your ever-loving minds. So if we had square root of 3,000, for instance, let's start with something basic. Let's go back to basics for a moment. Square root of 25. 5, right? What's another way we could express that square root of 25? Right? Mathematically, it's the same. Square root of 25 is equal to the square root of 5 times 5. Well, once we get 2 of the same number, under the radical sign, we can cross them out and bring 1 out, and we get 5. Everybody see what I did? Once we had a pair of numbers of the same numbers under the radical sign, so let's take another number. Square root of 49 is equal to the square root of 7 times 7, right? Once I get 2 of the same numbers under the radical sign, I can just cross them out and bring that number out, right? You guys follow what I'm doing there? I mean, it's really what you're doing in your head. I'm just doing it on paper. All right, let's do this. Now, let's take the square root of 125. That's a little more complicated, right? All right, let's re-express that as best we can. Why do we know that 125 is divisible by 5? 5 times what? 5 times 25, right?
Yeah.
We can also re-express 25, correct? We can say the square root of 5 times 5 times 5, right? What happens when we get 2 of the same numbers under the radical sign? We can cross them out, bring them out. So we'll cross out the pair, and we get 5 times the square root of 5. Is that a little easier than all that grouping mess we just did a moment ago?
Yeah.
To y'all? It is to me. I worked with the other one once upon a time. But if you'll go back and enter that in your calculator, you'll see that, you'll come out with a decimal, but you'll see that this equals that. So let's try another one. They had, let's try some weird number like 8420. So what do we know 8420 is divisible by? What can we look at it and absolutely know it's divisible by? 2. What else? 10. The bigger the number, the better. So we know it ends with a 0, so it's divisible by 10. We can, I'm probably gonna need this side of the board for it. So I'm gonna come back over here, and I'm gonna say the square root of 8420 is equal to the square root of 10 times 842, okay? All right, so now, what are those divisible by? Either one of those. We can do the 842 right now. What's it divisible by? 8 and 4 is 12, so it's not divisible by 3. We can do it by 2, right? We can do both numbers by 2, correct? This gets a little wordy, but if you'll stay with me, it's not bad. 10 is 2 times 5, right? 842 is 2 times what? 4 what? 421. So now, what we're trying to do is get to as many prime numbers under here as we possibly can. So is 421 divisible by 2? Is it divisible by 3? Nope. And I told my class, and I know some of you are coming from the other, how can you tell if a number is divisible by 3? If you add up the 4, 2, and 1, and that's divisible by 3, then 421 is divisible by 3. 4 and 2 is 6, plus 1 is 7, so it is not divisible by 3. It's not divisible by 4 because it's not even. It's not divisible by 5 because it ends in either 0 or 5. It's not divisible by 6 because it's not divisible by 3. It's also not divisible by 6. You can take your calculator. Will 7 go into 421? It won't. It'll go 60 and some change, but not quite an even number. 8 won't go in, not even. 9 won't go in because 3 won't go in. So bottom line, I think we're down to what is literally this. We'll cross those 2 out. 2 times the square root of 5 times 421, or 2 times the square root of 2,000. Somebody help me out here. 2,105. 5 times 421 is 2105. This Monday, I'm not sure I can math too well. But I happen to pick a prime number there. I don't think it's divisible by anything. So this value, did it with the calculator, should also equal that value in decimal form. So let's break out the calculator and see if we can. And I'll try to choose a little more wisely here next time. So the question is, review scientific. We do the square root, which is probably right in front of me, and I missed it. Here it is. 8420. Oops. Ah. You have to do this one backwards, don't you? Yeah. So we get 91.76 and all these extra numbers. And also do 2105 square root times 2, 91.76. So again, the same result without all that grouping and all that. So let's pick another number. I'll try to pick one that works a little better mathematically this time. We'll do 768. Do the square root of 768. what do we know 768 is divisible by? 2,
Two.
3. Because 7 plus 6 is 13, plus 8 is 21. So is 21 divisible by 3. So 768 would be divisible by 3. So let's take 768 divided by 3. That gives us 256, right? So we can re-express that as 3 times 256. Right? Hadn't changed. It's still 3 times 256. It still gives us 768. So now what is 256 divisible by? 2. If you know your squares, it's actually divisible by a much larger number. But if you don't, we'll go with 2. So let's rewrite it as 3 times 2 times 128. So 2 times 128 is 256, right? Alright. Let's come down here. 3 times 2 times, what is 128 divisible by?
4.
Divisible by 4. I like it. Alright. So that's 4 times what? 4 times 32. Alright. Let's keep going. 3 times 2. What is 4? What can it be represented as? 2 times 2. Now 32 can be represented as what?
8.
8 and what? Be represented as 8 and 4, right? Alright, let's keep going. And we're going to do some magic here in a second. 3 times 2 times 2 times 2 times, what is 8? So let's do 8 first. 2 times 2 times 2. What is 4? 2 times 2. Alright. We can start getting rid of a lot of them, right? 2 at a time. So here's 1. So we're going to re-express it as 2 times. Can't do anything with that 3, can we? So we're going to leave that 3 under here. We know it's going to stay. We can take this next pair and say 2 times 2. We can take this next pair and say 2 times 2. We can take this next pair and say 2 times 2. What is 2 times 2 times 2 times 2? 16. 16 times the cube root of 3. Or times the square root of 3. So let's whip out our calculator and see if mathematically, and I did all that in my head, pretty much, if we come up with the same answer. I can get everything where I can get to it. So we'll do 16 times, so we'll do, we got pen in hand, draft. Let's clear. This thing hates me. There we go. So we want to do 3 square root times 16. That gives us 27.712, right? Now let's take the square root of 768. We're looking to see if we get the same answer. So 760. Same thing. Now, would y'all rather learn groupings? Or does this work for you? I don't mind going back and revisiting that groupings, but this is what I've always taught in electronics is, which actually can be done in your math. Now I'll show you something here. You know, we can make this easier on ourselves at this point, and we're still going to arrive at the same answer. 128 is really 2 times 64. What's the square root of 64?
80.
So we can come out with 3 times 2 times 2 times 8 times 8. We'll cross out our pairs. 2 and 8. So it would be 2 times 8 over the square root of 3, or 16, or times the square root of 3. Comes out to 16. So anytime we see a square root value under there, we can go ahead and pull it out. So let's pick another number. Let's pick, hate picking random numbers, because every once in a while I'll pick a prime number. How about 495? Let's see what that works out to be. All right, what is that divisible by for sure? 5, right? 5 times what gives us 495? 99. Bless you. All right, well, 5 is prime. Bless you, we can't do anything with that. What can we get it down to? 3 times 33, right? All right, 3 is prime, so the only thing we got left we can work with is the 33. 5 times 3 times 33, what is it divisible by? 3 and 11. Get all prime numbers, you're done. 5 is prime, 3 is prime, and 11 is prime. But what can we bring out? We'll bring out the 3, which is here, so that becomes 3 times 5 times 11, or 3 times the square root of 55. Now 55 is not prime, but the only 2 numbers you can get it down to is prime. So let's see if our math works. So I'm gonna clear, I'm gonna do 495, and I'm gonna get the square root, 22.248. And I want you to notice something. I wish I could bring up 2 calculators here. These numbers will be exactly the same. There'll be no rounding. Everything out will be exactly the same. So if I take, say, 248,595, remember 248,595, don't try to remember any further. So I'm gonna take 55, I'm gonna take the square root, I'm gonna multiply it times 3, 24.248595, and all that is exactly the same. So this to me is a much easier method. I'll show you another way that, well, I probably won't, because I think that confuses as much as it does the same thing, but it's literally, it's a tree versus a way we're doing it. All right, how about another number? Let's go back to that one Nida showed us. Let's see if we can solve that same one. $28.35 was the original number, I think. $28.35. Let's do the Nida one. What is 28.35 divisible by? 5. So we can say square root of 5 times 500 and, how much?
567.
Thank you. 567. What is 567 divisible by? 3. It might be divisible by, it is divisible by 7, but it's also divisible by 3. So, what is 567 divided by 3?
81.
How much?
81.
81. Ooh. 567 divided by 3?
189.
Okay. I like the 81, but we'll go with the 189 for now. All right, what is 189 divisible by?
3.
Oh, guess what? I forgot already. I didn't put my 3.
That was my bad.
You're not the first person I put to sleep, and you won't be the last.
Yeah, good question on there, man. Yeah.
They're falling out of their chairs and fun. All right, so 5 times 3 times, what's the 189 divided by? Divisible by? 3. What does that go in? 63. 63. What is 63 divisible by? 3. So we can go 5 times 3 times 3 times 21, right? Except I missed a 3. 3 times 21. All right, we're going to have to come over here because we're out of room. So let's square root of 5 times 3 times 3 times 3 times, what's 21 divisible by?
3.
3 times 7, right? All right, we got two pairs of threes we can bring out, right? So let's do it. We'll take this out, that becomes 3 times the square root. Take that one out, that becomes 3 times 3 to the square root of 5 times 7. So 9 times the square root of 35. And let's see if mathematically we arrive at the same answer. So I'm going to go 35 square root and then times 9. We get 53. I'll even write a few of those out. 53 point. All right, I ran out of board. I'm going to clear it, and I'm going to do 2835. And I'm going to do the square root. 53.24418489654. So exactly. That's way easier than grouping to me. If you want to know grouping, stick around. We'll work through it
I
together.
thought you were calling that grouping because you were taking out.
I'm slicing here rather than grouping. This just makes more sense because it's a mathematical. The other one's probably mathematical too. My brain wraps around this much easier than it does
That
this.
whole doubling the quotient,
Huh?
that doubling the quotient thing.
Yeah, it gets a little wonky in my brain. So let's do one more. And then I'm going to dismiss y'all to go up yonder. You have to. Let's do the square root of, why not, 85. All right, what do we automatically know that's divisible by? 5 times what? Use calculator. 17 what? 17. That may have been a bad choice on my part. 8 and 8, 16, I think I picked the prime number. That's right. Well, it's divisible by 17. Let's see how much further we can go there. What's 17 divided by 17? 101. I can go ahead and tell you. That was a bad choice.
You got it.
So, let's pick another. I told you I'm good at finding these wonky numbers. Let's see.
Could you just have made that like a even number?
Yeah, I could. We'll do something divided by 3. I'll still probably end up with a wonky number, but here we go. There we go. 1536. What is that divisible by for sure? 3. Yep. 1 and 5 is 6, plus 3 is 9, plus 6 is 15. So we'll say 3 times what? 512. What is 512 divisible by for sure? All right, so 2 times 256, right? Let's keep going. 3 times 2 times 2 times what? 128. Let's go one more and then something should happen magically. 3 times 2 times 2 times 2 times what? 64. Now what do we know about 64?
8 times 8.
8 times 8. So let's sum this up quicker. 3 times 2 times 2 times 2 times 8 times 8. All right, we got some pairs. First pair, right here. 2 times. Second pair, right here. 8. So let's do the math. 16 times the square root of 6. Let's make sure we calculated correctly. So I'm going to do clear. I'm going to do 6 square root times 16. We get 39.1918. So let's come back to the original number. 15, the what? Oh. Alright, so 15, 30, originally or just then? Okay. 39.1918 and all these other numbers. So we arrived at exactly the same thing, and we didn't have to do any grouping. So we're gonna see if we got smart. We're gonna go to the practice real quick. Actually, I guess we'll go to the final quiz. What is -4 to the -2nd power? Give me just a second. Just a second. I'll zoom in on that a little bit. So what is the first thing we've got to do? Convert it. So we got -4 over 1 to the -2nd, right? All right, so now we've got to invert that, so it becomes negative what? And what do we do to that power? It stays with the 4, right? But it becomes what? It becomes positive. So it's -1/4 squared, so that literally translates to -1/4 times -1/4. And that equals what?
16.
Yep, if we divide 1 by 16, we get 0.0625. So it should be C, correct? Because negative times a negative is positive. So anytime anybody insults you twice, just remember that. What is 25 to the 0 power? What is 5 squared?
25.
25. What is 5 to the first power?
5.
5. What is 4 to the -2nd power? I'll give you just a minute. What's the answer? C. Same as earlier, because what happens is this 4 is really 4 over 1 to the -2nd. Oh, wait a minute.
D.
So 4 to the -2nd.
I'm still right, you got a positive 4.
Say that again?
Still C, ain't it?
Yes. Isn't it?
Yeah.
So it becomes what?
1/4
1/4
times 1/4.
squared, right, times 1/4. Yeah, sorry, my brain left me for a moment. So it becomes 1/4 squared, which equals 1/4 times 1/4, which equals 1/16, which equals 0.0625. Well, I got it was two negatives that became positive this time, which is simply positive that remains positive. And that's why my brain, and that's why NIDA throws you these little curveballs. Just mess with people like me. All right. Square root is represented by what? Radical, dude. Channel your inner teenage mutant ninja turtle. Which number indicates a square root? B. Radical. What is the square root of 1? 1. What is the square root of 144? 12. Now we know that, but let's see if our little trick, if we didn't know that, would work. So we started out with the square root of 144. Obviously, we knew that was 12 by 12, 12 times 12. But we also know it's 2 times 72, right? Which would be 2 times 2 times 36, which would be 2 times 2 times 2 times 18, which would be 2 times 2 times 2 times 2 times 9, which would be 2 times 2 times 2 times 2 times 3 times 3. I don't know why I wrote the regular times there. I've been putting dots for everything else. 3 times 3. So we come out with 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. There it is. So even our little trick there, if we didn't know, would work. So, 12. All right. What is the square root of 1.5625? You should know that just by looking on that board. Well, maybe not. There's one trick. It is 1.25. And I'll let you use the calculator. Oops. Let's change the answer. So we want 100, not 90, because we forgot the answer one. Hundred. Okay. So any questions on square roots? Again, if you ever want to work that grouping, give me a day's notice. And I'll be glad to show you the grouping. I'll need some time, but I've used that other one to more success than I have the other. See those that test out. See you in the morning at 8 o'clock. Sales on. Yeah, go see WIOA if you're a WIOA recipient. They're going to show you how to fill out your time sheet and